Good morning, students. Today we are going to see the topic data definition language. So it is commonly called as DDL. So DDL is used to define and manage the structure of a database. Before we can store any data, we first need to create the database objects such as tables. Some common DDL commands are create, alter, drop and truncate. In this slide you can see the create table command for an instructor table. Here we define different columns like ID, name, department name and salary along with their data types. Whenever a table is created, the DBMS stores its definition in the data dictionary. So it is known as metadata, which means data about the data. It stores information such as table names, column names, data types, constraints and user permissions. DDL also allows us to define integrity constraints. For example, the primary key ensures that every instructor has a unique ID. This prevents duplicate records and maintains data accuracy. So DDL is mainly used to create and organize the database structure before inserting any data. The next one is data manipulation language. After creating the database structure, the next step is working with the actual data. This is done using data manipulation language, that is DML. So it is used to insert, retrieve, update and delete the data stored in the database tables. Some common DML commands are insert, select, update and delete. This slide also explains two types of DML, procedural DML and declarative DML. In procedural DML, the user specifies both what data is required and how to retrieve it. Second one is declarative DML. In declarative DML, the user only specifies what data is needed and the database system decides how to retrieve it. So SQL is an example of declarative DML because we simply write the query and the DBMS finds the best method to execute it. Since declarative DML is simple and easier to use, it is the most commonly used approach in modern databases. The next one is SQL query language. So which stands for structured query language. SQL is the standard language used to communicate with relational database. It allows us to create tables, insert data, update records, delete records and retrieve information. In this slide we see an example SQL query. The query selects the names of instructors whose department is computer science. The select statement specifies the column to display. The from class specifies the table. Where class filters the records based on the condition. SQL is a non-procedural language, meaning we only tell the database what information we need. DBMS automatically determines the best way to retrieve it. So in real world, SQL is often used together with programming languages such as Java, Python or C# to build complete database applications. So next one is database access from application program. So normally users do not write SQL queries directly. Instead, they use applications such as college management system, banking software, hospital management system or online shopping websites. When a user clicks a button like login, search or register, the application automatically sends SQL queries to the database. These applications are written using programming languages like Java, Python, C# or C++. The programming language communicates with the database through database connectivity tools such as JDBC, ODBC or other database drivers. For example, when a student logs in to the college portal to view marks, the application sends an SQL query to the database, retrieves the required information and displays it on the screen. So users interact with the application while the application communicates with the database using SQL. So next one is database design. So database design is the process of organizing the data efficiently before creating the database. There are two important parts of the database design. First one is logical design and second one is physical design. In logical design, we decide what table should be created, what attributes each table should contain and how the tables are related. For example, in a university database, we decide whether to create separate tables for students, faculty, courses and departments. In physical design, we decide how the data will actually be stored on the storage device for better performance. So good database design reduces duplicate data, improves consistency, speeds up data retrieval and makes maintenance easier. A well-designed database is efficient, secure and easy to manage. Therefore, database design is one of the most important steps in developing any database applications. So today we learned about data definition language, data manipulation language, SQL query language, how applications access databases and database design. These concepts are the foundation for learning SQL programming and understanding how real-world database applications are developed. So in the next class, we will continue with the database engine and database architectures. Thank you everyone.